Hello everyone, my name is Pauline Trainard. I am thrilled today to give this webinar to show you the new features of the MonolixSuite 2024 R1, the latest version of the MonolixSuite. This webinar will be recorded and it will be available online tomorrow on our YouTube channel. Please write your questions in the Q&A chat box of Zoom, and we will answer on my colleague Geraldine will answer directly. And if time allows at the end, some questions will be answered already. So we try to continuously improve our software to better answer to your needs. And as usual, based on your feedback, we have brought large and small updates to all our applications, either with new functionalities, but also improvements of existing ones to make your whole analysis workflow more flexible and efficient. So we have brought updates to Monolix, our software for model estimation, PKanalix for non-compartmental analysis and compartmental analysis, and Simulix for simulations, as well as our data formatting and reporting modules available in Monolix and PKanalix, and the Lixoft connectors R package, which is the MonolixSuite API for R. And in this webinar, I will walk you through most of our new features for each of these applications using some examples of PK analysis. You can find more information about the new features on our documentation website on monolixsoft.com. And you can also download there the version to try it yourself. Before I start the demo, let me give you a quick overview of the main features. First, Monolix has a new major feature, which is a Bootstrap module that is part of the interface, which has adjustable settings and lets you track the Bootstrap results while it runs. Second, you can now define and transfer presets of plot configurations across plots within one project, and also across projects, which will accelerate your plot exploration and customization. And you will see that this new major feature is also available in PKanalix and Simulix. New results such as confidence intervals and parameters or typical values for modalities of covariates, and options in the plot such as the possibility to define several versions of a plot or to replace time with a regressor as axis variable also provide you with more information on your analysis and more ways to visualize this information. We have also improved the performance of Monolix that is now much faster to reload projects and plots, and this makes it now possible to enable the automatic creation of plots when reloading a project. Performance for projects with time-varying regressors has also been hugely improved when an analytical solution is available for the predictions, as this analytical solution is now used in a piecewise manner, while it was not used before. And finally, you have more flexibility on the possible input and output dataset formats, as Excel and SAS file can now be loaded directly into Monolix, and these formats can also be used for exporting formatted data. In PKanalix, the selection of NCA parameters is more user-friendly, and it is now possible to define ratios of NCA parameters across occasions and custom NCA parameters as formulas of existing NCA parameters and covariates. As in Monolix, presets of plot configurations and new options of plot customization, such as a new NCA data plot displaying the data as used for NCA, or the possibility to display nominal time, will make your life much easier to produce your customized plots for your reports. And it is also possible to define data formatting presets to automatize the data formatting part of the workflow. The new flexibility in the input data format is, of course, also available in PKanalix. Furthermore, another new major feature is a Sparse NCA mode that automatically calculates mean profiles for all groups of individuals you have defined. And finally, your NCA results now include a table of all concentration samples used in the analysis that you can include in your report. In Simulix, there is a new button to automatically add a block of inter-individual variability in the model, which is very convenient when you want to simulate a model from scratch. You have the same plot presets as in Monolix and PKanalix. You can choose to use regressors with linear interpolation between the times at which they are defined, instead of last value carried forward, which remains the default. And this provides more flexibility for your model predictions. And this new option is also available in the other apps of the suite. You also have more flexibility in the definition of the regressor elements, since regressors that are constant in time can now be defined as distributions of values. Moreover, it is now possible to export all covariates from a Monolix or a PKanalix project and not just the ones used in the model and use them in the simulations. Finally, when simulating a study endpoint over replicates, the percentage of success for this endpoint is now reported with a confidence interval to give you more information on the power of your study. So let me now show you how these features work in practice, and during the demo, I will also surprise you with many more smaller features. So here is the first project that I would like to show you, and I can right away show you a cool new feature of the interface. When I hold the control key of my keyboard, I can now zoom in and out of the interface using the wheel of my mouse, like this, which is super convenient to adjust the size of elements to a bigger screen or to share my screen and keep the interface easy to read for everyone. In this Monolix project, I have loaded this preclinical data set in which 12 monkeys have received multiple doses of some drug with a higher loading dose and then lower maintenance doses once a day. And we want to consider dose dependency in the PK model. The dataset includes the level of the last dose as in a column dose that I have tagged as regressor, and weight, which is equal to a typical weight of 4 kilograms for all individuals, for all monkeys. This covariate will be useful to apply allometric scaling and simulate a clinical study in humans just by changing the weight values. In addition, the monkeys are split in 2 groups, receiving slightly different formulations of the drug, which is indicated in the column form. So you may have noticed several small changes in this tab compared to the previous version, so let me list them all. First, notice that this data set is an Excel file. I can show you it here. And I was able to load it directly into Monolix without having to save it as a CSV beforehand. Indeed, a new feature of MonolixSuite is that Excel and SAS files are now compatible input files. And here is the sheet that I selected to read from the Excel document. Second, if you realize after loading it that your dataset needs some formatting, for example, to add those lines or additional columns, you can send the dataset directly to the data formatting module with this new button. Next, you can now use this radio button here to choose how to interpolate regressor values in the predictions. In this case, if I enter the data edit mode, like this, I see that the initial data has a record 200 at time 0 for the dose regressor, and then no record until 100 at 24 hours, which is the time of the first maintenance dose. So to interpolate the values between these 2 times, I now have the choice between the last value carried forward behavior that was already used in MonolixSuite and this new linear interpolation option that can produce more realistic predictions between the times at which the regressor is defined. So in this project, with last value carried forward, the predictions for those would stay equal to 200 until 24 hours, while with linear interpolation, it will decrease slowly between 0 and 24 hours. And in my case, I will keep the default behavior on the left. Moreover, we have added this icon as a shortcut to send the current header types taggings to your preferences, so that the next time you import a similar data set, the columns will be automatically tagged with the same types. For example, here, all my column headers except those are already associated with the default tagging in my preferences, and I could add those header to my preferences to always tag it as a regressor. Speaking of column tagging, one nice improvement is that if I now load another dataset instead of this one, my column tagging will be kept for all columns with the same headers, which is really nice when you took some time to tag a large number of columns and you just want to update your dataset with a different version of the same data, for example. And another update in this tab is hidden in the warnings that Monolix raises when you load the dataset to let you know if there are possible issues that you should check in the data. So here, if I would load this dataset now, it would warn me that weight takes only 1 value, but it no longer states that that covariate will not be used. And indeed, Monolix now keeps constant continuous covariates in the statistical model, which can be convenient for allometric scaling, for instance, as I'm going to show in this example. But first, let me show you the structural model that I have used. It is a simple PK model with 1 compartment with volume V, the first order absorption with absorption rate Ka, and the clearance Cl. And in addition, I have implemented a bioavailability that increases with the dose level. with a maximal bioavailability of 100% and a parameter D50, which is a dose at which the bioavailability is 50%. And you may have noticed this indication here that is new. So as you know, Monolix solves PK models written with PK macros, such as this one, with analytical solutions if they are available, which is not always the case. For example, if the model includes transit compartment or nonlinear elimination, there is no analytical solution and the model is solved as ODEs. So now all the cases where an analytical solution is available are clearly stated. As I mentioned at the start of the webinar, remember also that in the case where the models include a time-varying regressor, Monolix now uses piecewise analytical solutions, while before it would use an ODE system. And this makes the estimation in these cases much faster than with the previous version. I will now show you quickly the statistical model before moving on to the estimation results. So I have set no random effect on D50, and I have added a covariate effect of form on D50 and covariate effect of log T weight, which is the log transformation of weight divided by 4 on the volume V and the clearance. And as I have mentioned, weight is the same for all the subjects, so no covariate effect can be estimated, but instead I have fixed the corresponding betas to 1 for V and 0.75 for CL. And this way, the parameters CL and V follow the usual allometric scaling formula. And when I will export the Monolix project to Simulix, it will be possible to simulate easily a human population by setting a weight distribution around 70 kilograms, for example. So now this project has already run, and before I show you the new features provided in the results, let me present first the performance improvements for this version. I already mentioned the new piecewise analytical solutions with time-varying regressors that make the estimation much faster in these cases. In addition, we have optimized the MCMC settings to accelerate the population parameter estimation by 7% on average. We have also improved the calculation of the standard errors by decreasing the tolerance of the ODE solver used in the calculation of the Fisher information matrix in the non-stiff case and excluding time-to-event models. And also by enhancing the conversion of the relative standard errors from Gaussian to non-Gaussian domains. So instead of the Jacobian approximation that tend to underestimate relative standard errors for highly nonlinear transformations and high relative standard errors, Monolix now uses an exact formula for log-normal parameters and numerical integration for logit and probit normal parameters, so the values are more precise. We also now provide two settings, ODE appstol and ODE reltol, that can be used within the structural model file to modify the ODE solver absolute and relative tolerances, which may help solve numerical issues that could occur in particular instances with complex models. And finally, we have improved the installer that is now much faster. So now I can show you the results in this project. And as you can see, all parameters have been well estimated, except omega Ka that has an RSE that is larger than 50%, but it's not that big. And you may notice a difference in this table compared to the previous version. Now, in addition to the standard error and relative standard errors that are reported here, we report also the confidence intervals for the population parameters. By default, it is the 95% confidence interval, but you can change the level in the settings of the standard errors task here. In addition to this new information on the confidence, you can now easily assess the confidence on your population parameters via Bootstrap, which is integrated in the interface. And this is a particularly valuable approach if you are facing issues such as nans in standard errors due to numerical errors in matrix inversions, or biases in the results caused by incorrect assumptions of asymptotic normality for parameter estimates. And Bootstrap overcomes these challenges by sampling many replicate datasets and re-estimating parameters on each replicate. So to access the Bootstrap module, you can either click on this shortcut next to Run and next to the shortcuts that were already available for convergence assessment and model building, or you can go to Home, Perspective, and Bootstrap. And here, all these settings can be changed. So you have the number of Bootstrap replicates, the tasks to run in addition to SAM, can be standard errors, log likelihood, with or without linearization. Whether Bootstrap runs should start their estimation from the same initial values as the initial run, or from the final estimated values from the initial run. The type of Bootstrap. So in non-parametric Bootstrap, new data sets are sampled from the initial data set for each replicate, while in parametric Bootstrap, new data sets are simulated from the model for each replicate. Here you have the sample size. By default, it is set equal to the size of the original data set, but it can be adjusted for computational efficiency. Then stratified resampling allows to preserve the original distribution for categorical covariates. For instance, I could make sure to keep half of the subjects in each formulation group in the sample datasets. Then you can also choose the confidence interval level to report for each parameter. Since having a large number of new data sets and results may take some space on your disk, you can choose whether to save the sample data sets and the results or not. And finally, you can choose to replace or not Bootstrap replicates that have a failed convergence, meaning that the autostop criterion for the exploratory phase of SAM was not met. And then you can run. So now I will load the same project, which has already Bootstrap results, to show you the results. And these results include tables with all the Bootstrap estimates for the population parameters, also for their relative standard errors, and for the objective function values if these two tasks have been selected in the Bootstrap settings. And there is a button for each run that allows me to load it in a separate Monolix window if I want to have a closer look at its results. Then I have tables of summary statistics on the Bootstrap estimates, including the reference estimates, mean, standard errors, and relative standard errors, and the confidence interval and the median, and also a bias, which is the relative difference between the reference estimates and the mean. And we have the same tables for RSEs and objective function values. Then we have also plots, such as the distributions of Bootstrap estimates that are shown as box plots or as bar plots like this, with also the median, reference estimates, and confidence intervals that can be displayed as well. And we have the same plots for relative standard errors and objective function values. And finally, there is a plot showing the evolution of the medians and confidence intervals of the population parameters over the Bootstrap samples. And this plot is also shown in real time while you are running Bootstrap, which is convenient for you to check whether your Bootstrap estimates converge. So to show you how it looks like when it is running, I can resume this Bootstrap by adding more runs. And if I keep all other settings identical, Monolix can reuse the already existing results and resume Bootstrap only with the new runs. So when it is running, Monolix shows the table of population estimates from all runs already done, with some summary statistics and an estimation of the remaining time. And it shows also the plot of medians and confidence intervals. That's shown here. And now that you have seen this, I will stop it because it would take much too long. So on this matter, since Bootstrap can be very time-consuming, I will show you on the slide that Bootstrap in Monolix can be used with distributed calculation on a cluster, as is the case also for convergence assessment and model building. And all the settings of these tasks can now be specified in the command line by giving a detailed config file. Now I will come back to estimation and show you again the table of population parameters, where the Bootstrap results are also reported, which gives a full overview on the confidence metrics that we have for each parameter from the different approaches. And now I will move on to the other updates in Monolix results and plots, starting with this new toggle that appears when categorical covariate effects are used in the model, such as the effect of formulation on D50 in this case. And when it is toggled on, a new section appears with the typical values for D50 in each group, including the estimated standard errors. Another new information is provided in the result of the individual parameters. So we have shrinkage that is reported on the shrinkage of the individual parameters that is reported in the summary tables of conditional modes and conditional means. And note that we have changed the way the shrinkage is calculated in Monolix. It is now based on the standard deviations rather than on the variances. I will now show the updates in the plots. So in the plot of observed data that I have split by formulation here, there is a new toggle here in display that allows to hide or show sensor data. And this is useful to see better the shape of the curves without the bias produced by the sensor values. In addition, on this plot and also on the VPC, it is now possible to choose the variable for the x-axis among time after the last dose, or any regressor from the dataset. In this case, the only option is dose, which is my only regressor from the dataset, and it takes only 2 values, so it is not so useful. But this feature is great, for example, to display response versus exposure, if you have response data and exposure as a regressor, or to display the time with the different units, if you have another time column tagged as a regressor in your dataset. And with all the flexibility that you have in the plots, you may want to define several versions of a plot with different settings, for example, with different variables on the x-axis or with different scales on the y-axis. In this version, it is now possible to do this and save these plot occurrences in the project so that they are regenerated with the different settings when you reload your project. So to generate, for example, another occurrence of the plot observed data, I'll go to the list of plots next to the task. And I can now define the number of occurrences I want for each plot, number of copies I want for each plot. And I can generate them by rerunning the plot task. Or there are also shortcuts to, for example, directly increment the number of occurrences for one plot and generate the new occurrence right away, which is also equivalent to increasing this number here to 2 and regenerating the plot with this green arrow. And now I can choose a log scale for my second occurrence that appears here. And this setting will be kept when I reload my project. And the second plot version will also be included in the default report that I can generate in one click with the reporting module. But the biggest new feature for the plots corresponds to this new panel here that allows to transfer plot settings and preferences from one plot to another and to define and apply presets for plot configurations. For example, if I want to have several plots stratified by formulations like this version of observed data, instead of applying the stratification manually as I go through the list of plots, I can just transfer the stratification settings from this plot to the other ones by clicking on Apply. So here I will apply the formatting selected in this copy of observed data to the plots that I want. For instance, my second version of observed data in log scale, the observation versus predictions plot, and the VPC. And here I will apply the by default the formatting options that I have selected from the Stratify panel. So the options here, and the preferences panel that is here that corresponds to the colors and size of all the objects from the plot. And if I want, I can also select the options from the settings panel, which corresponds to the elements displayed or not on the plot or the scales for the axis. Here I will choose to transfer only the stratification. So after applying this, I can see that the stratification has been applied in all the plots I have selected. Like this. Another possibility that you may have seen in this window is to apply plot formatting not from a plot, but from a preset. And Monolix includes these 2 predefined presets available for your use, but I will also show you how you can define your own presets. First, this typical reporting setting that I will apply to all my plots correspond to plot settings typically chosen to report the analysis results, such as observed data and predicted percentiles for the VPC, or on observation versus prediction, you have the population plots in addition to the individual plots, and it removes the grids in the background. Then the grayscale preferences preset will impact only the preferences that are here to produce publication-ready grayscale plots with optimized formatting. You can see it as well on the VPC. And as you can see, in addition to the changed colors, the size and spacing of the text have also been changed to improve readability of the plots. Now, if I want to restore the previous plot formatting, I can click on Reset, which will reset all plots to the system default. And now to define your own preset, you should first set up your plot configuration as you would like. For example, I will stratify my VPC by formulation. I will choose a log scale on the individual fits. And in my first occurrence of observed data, I will choose the logs. I will increase the zoom preferences, which is here, which is also a new cool feature of this version that allows to increase the size of all elements of the plots. So I will increase it to 150. And now I can save all these options by clicking on Save. I give a name to my preset. I could choose to ignore part of the options from Stratify, Settings, or Preferences, and I could add a description. And finally, I can also choose to set this preset as my default, which means that when clicking on Reset, the plot configurations from this preset will be applied if relevant. And after saving it, it will be available in the list, so here, and also in the list to choose from when I click Apply. And in this Manage Plot Presets window that I can also open at any time by going to Settings, Manage Presets, and Plot Formatting. Here I can modify or remove some of my custom presets, and I can also export or import them as separate files that are saved with a Lix preset extension, which means that you can very easily share your preset with your colleagues to uniformize your plot configurations in your company. And the last thing I want to show about the plots is what happens when you reload a project with results. So I will reload my project. Note, by the way, that since I didn't save the changes I made to this project, so I have the star here, we have added a new warning to make sure that I'm okay with this. And we have also improved the warnings that occur when you run a project that has not been saved, or that a project that already has results that would get overwritten. So now with these warnings, you have all the security checks to avoid losing your work. And here I'm okay to discard the changes and just reload my project as it was before. And when I reload my project, in the previous version, I would need to rerun the plots task to regenerate the plots, while now, look at that, they are automatically recreated. And this is a behavior that makes it easier to work with your project and that you can enable in your preferences. So here corresponds to this preference. And this behavior is possible because by default, the charts data from the project are now stored as a binary file with the results and can be loaded quickly. So the model simulations that some plots require, such as the VPC, do not have to be repeated. And if you find that this takes a bit too much disk space, you can turn this off. And the same method is applied for the dataset, which is now normally stored as a binary file in the results folder, which makes the project reload much quicker. Now I will show you the two new features located in the export menu. The first is Shared Project, which lets you automatically create a zip folder with all the files you need for your project. And this includes the dataset and the model file, unless it comes from the libraries, and the results folder if it exists. So they are all saved in the same location so that the person who gets this zip can easily unzip it and load the project without any problems of missing files or incorrect paths. And this is very handy for sharing your project with colleagues or a regulatory agency, for example. Another new feature in export is that you can now export your project to Sycomore in addition to PKanalix and Simulix. So as you know, Sycomore is a companion app for Monolix that lets you view and compare your Monolix results. And this export will create a new Sycomore project with your Monolix project already loaded. Here, everything takes a bit more time because I'm sharing the screen for the webinar, but here it is. And so you have this this project with this Sycomore project with the Monolix project already loaded, and you can quickly scan the parent directory to load other Monolix projects that are located in the same folder, or you can use the menu to add other directories or projects. And additionally, we have eliminated some limitations in Monolix that we had after the project was changed to improve the workflow's intuitiveness. So let's say that I need to refine my model with some change to the statistical model, for example, to add a covariate effect of form on Ka as well as on D50. Typically, I would then save my project under a new name and rerun the estimation. And to have a fast estimation, it would be best to start from the last estimate. And this is what the button Use Last Estimate All here is for. But previously, this action was not available after adding or removing any parameter in the list, such as this new parameter here. While now, this action is always available if there are existing results, and only the parameters that have not changed have their initial values updated. Another constraint that we had after modifying the project and running the tasks again was that all the plot options that I had previously selected in settings, stratify, or preferences were lost if I had not saved the project with them, while now they will be restored even in that case. And finally, I would like to mention that all the new, that we have a new warning here to warn you when your project settings are now inconsistent because you have changed something in your model and you have not rerun your tasks yet. And another thing is that all the new features that we can see in the tables of the results are, of course, also available in the report, and in particular in the default report that you can generate in one click here with Generate Report. And this is the end of the Monolix demonstration for this webinar. So next, I will present the new developments for PKanalix and Simulix. But keep in mind that some of the features that I demonstrated in Monolix are also applicable to PKanalix and Simulix, such as the linear interpolation for regressors or the plot presets, for example. So I won't repeat them. So I will open PKanalix. I will close my Monolix project. And I will open PKanalix to create a new project. And I will load the dataset for my first example. Here it is open on my other screen. So new project, and my dataset needs some formatting to be read by PKanalix, such as replacing some censoring tags by the limit of quantification and adding those lines in the data. So I will load it with format here. And the columns in this project are subject ID. I have nominal and actual times and PK concentrations that, as you can see, contain some BLQ samples with this tag here. And the concentrations have been measured on the first visit on day 1 and also on the last visit on day 14 in a multiple dose study. So the visit is indicated in this column day. And there are 3 different dose levels indicated in these domed columns. And finally, 3 covariates are included. So I start by initializing the data formatting by selecting ID, time with actual time, and day as sort, in order to distinguish the profiles from the first visits and the last visits. Then I click on next, and I have to define my formatting operations for the observations to specify some BLQ samples and for the treatments, because those lines are missing from my dataset for now. But if this formatting is always similar because my input data format is frequently the same, then it is quite cumbersome to manually perform this formatting each time I create a new project. And we actually had many requests from users to automatize this. So I'm happy to introduce a new solution for this available in this version, which is here. Similarly to the plot presets that I have just shown you in Monolix, it allows to define and apply data formatting presets to your project. And here I have already defined a preset that contains the formatting operations I need for this project, and I can apply it like this. And this preset specifies that the column dv microgram milliliter is the observation column, and that all detected tags in this column, so all values that are not numbers, should be used as censoring tags and should be replaced by the LOQ extracted from the same column, so extracted from the tags. In addition, the preset contains the definitions of several treatments that will be added as dose lines in the dataset. And each treatment is specific to the subject from a dose group. And this possibility to define treatments for only groups of individuals is also a new feature for this version. So individuals from the low dose group will have a new dose line at time 0 with an amount of 200, sorry. And those from the med group will have an amount of 400. And finally, the last group has the highest amount of 800. And as for the plot presets, I can also easily create a new data formatting preset with the new button, like this, that will save the current data formatting choices for initialization, observations, and treatment. And I can see my list of custom presets by opening the same kind of window like this, by going to settings, manage presets, and data formatting. And here I can also create, remove, or import or export data formatting presets, just like for plot presets. And I can also check their content. Indeed, contrary to the plot presets, here the description of a new preset is automatically filled with, when I create it, with the list of the formatting operations specified in the preset. For example, here we see the initialization of the columns, the definition of the censoring for the observation column, and the 3 different treatments corresponding to the different groups of those. And that's it for the data formatting presets. And before I apply this formatting to the data, I would like to show you another new data formatting option that is here, although I will not use it in this example. So in the previous version, it was already possible to define those intervals as occasions, which means that when applying multiple doses, you could distinguish each interdose interval with an occasion to be able to analyze separately the PK profiles following each dose. I will show you on the slide. I have a slide that makes it clearer like this. So you could distinguish each interdose interval with an occasion. But if there was a concentration at a dose time, like this one here, it was assigned only to the occasion of that dose, even though actually it would also correspond to the last concentration measurement from the previous profile. So now we have a new option that allows to duplicate such observations to consider both as the last measurement from the previous profile and the first measurement of the profile given the profile after the given dose. It corresponds to this checkbox here. But here I will not use this, and I click preview, and I obtain my formatted data set. So I need to tag the columns. You can see that 3 new columns have been created by data formatting with the occasion ranks in DAOC, those amounts in IMT, and the censoring flags in sense. And my covariates have been automatically tagged, except those that I will tag myself as categorical. Finally, in this version, there is I have here my nominal time column, and I can use the new nominal time column type to tag it, and that will allow me to display that nominal time in the plot, which I will show you now just after setting up the units. Like this. And this gives me the opportunity to show you that we have included a bunch of new units, such as international unit, becquerel, or milligram equivalent. Here I choose microgram, and I accept. And then I will show you the plot of observed data, where we see the concentration time curves based by default on the actual time. And now in axis, I can choose to use the nominal time instead on the x-axis, and the default axis label is also updated. Now I will guide you through the many updates in the NCA settings. I will focus first on this part of the window. So in the calculation settings, I should first set the administration here as extravascular. And I will use this new option that allows to define an interdose interval for single dose profiles. And this is convenient in cases such as here, where the PK profiles are distinguished by occasions as if there were individual profiles, but we still want to calculate steady state parameters such as AUC tau on each occasion. So I just have to specify the value of the interval here. And all the NCA steady state parameter can then be calculated as well as the parameters usually for single doses. So I can now select the parameters I want to compute in this panel. And this part is now easier because, as you can see, we have improved this panel for parameter selection. Now we use checkboxes to select the parameters, and the parameters are grouped in sections. So I can easily check that AUC tau and AUC tau divided by the dose are selected in the AUC section. Then I will check that in the concentration section, I have C tau that is selected. And for instance, in the volume clearance section, I can check that the steady state clearance is selected. And I can also display the parameter aliases in that table. So if you remember, the aliases are defined in the preferences and will be used in the result. And I can hide unselected parameters to focus only on the list that I have selected. Moreover, you may have noticed on the top a new option to define custom parameters. So when I click here, I can either define a new parameter with a formula using existing parameters or covariates, or I can select some of the custom parameters that I have already saved in my preferences. For example, here, I will add the clearance divided by the weight, and I will edit it to show you how I have defined it. So I have entered a name and an alias to use in the result that can be formatted with subscripts and superscripts. And I have a formula that uses this parameter CLF ops and the covariate weight. And I have defined also units for this new parameter. And finally, another new option here allows me to define ratios of NCA parameters calculated between occasions. So I will define the accumulation ratio like this between the days 1 and 14 based on the parameter AUC tau divided by the dose. And I can see the formula corresponding to this ratio here. This will be a new parameter corresponding to each individual. Note that I could define a ratio based on any occasion or covariate columns or covariates that corresponding to the different occasions and any NCA parameter. So I create it. And before running NCA, I check that the lambda z is well estimated on all individuals with the default selection of plots. I'll zoom a bit. And for the sake of the demo, I will change the selection for the first profile so that it doesn't follow the general rule like this. And then I will run NCA. So before I run, you may have noticed this Sparse NCA toggle here. I will explain this in a second example after this run. And when I click on run, you can see another one of the new warnings that we have added to make your workflow more secure, because here my project is still unsaved. So PKanalix warns me that, of course, I won't keep my analysis results if I don't remember to save it somewhere at some point. But I can decide to run it anyway. Now I will get the results, and in particular the table of individual NCA estimates that I will show you first. The interface takes a bit of time to update. Usually it's faster when I'm not sharing my screen. And here in this table of NCA individual estimates, you can see the custom parameter CL divided by weight that I have defined. And also, if I scroll to the right, you see a new flag corresponding to the rule used for to calculate the lambda z. So 1 means that the general rule is used, while 0 means that there is a specific selection. Then the accumulation ratio is shown in a dedicated table here with one value per individual. And there is also a summary table with the usual statistics. And of course, I could define several ratios corresponding to several parameters. But there is also another new tab here compared to the previous version. The concentrations tab displays a table of concentrations used for the NCA analysis. So it uses by default the nominal times, but I could choose to use the actual times instead. And it shows summary statistics for all the concentrations at each nominal time. But it would be also possible to display the individual concentration profiles like this for each subject occasion, with the concentrations below the below the limit of quantification displayed like this. And it would be possible to split this table by groups of individuals based on categorical covariates in the dataset. That's for the new features in the results. And there is another new feature in the plot. So in addition to the new features that I have already shown in Monolix, such as the plot preset or the toggle to hide sensor data in observed data, there is a new NCA data plot that shows the concentrations as they are used for NCA, which means that in particular, concentrations below the limit of quantification, so the ones in red, are displayed using the values specified in the NCA setting. So here it would be 0 before Tmax and LOQ divided by 2 after Tmax, instead of always being displayed as LOQ as in the observed data plot. And in addition, if you have concentrations before the last dose that would be excluded from NCA, they would be excluded from this plot as well, while they are not excluded from the observed data plot. Now I still have to show you the sparse NCA mode. And for this, I will load the new demo project called Project Sparse here. This is a demo project that gives a nice example. So in this project, the data has been collected in mice, and it is composed of a single concentration measurement per subject that we can see here. For example, this is the concentration sample from subject 85. So of course, I wouldn't be able to perform NCA on the individual data, but I would like to do so on the mean concentration profiles that we see here, where the data has been stratified by 2 covariates, study and dose group. And thanks to the new sparse NCA mode, it is now possible to do so automatically. So I can define here the stratification I need for the sparse data. And the corresponding mean profiles will be automatically calculated based on the nominal times and will be used for NCA. Since there are concentration samples below the limit of quantification in this data set, I can also specify how to use them in the calculation of the mean. So by default, there is a single rule that is applied to replace these samples by one of the usual options. But to give more flexibility, more complex rules are also available that combine 2 rules based either on the fraction or the total number of BLQ samples. For example, if I have more than 1/3 of BLQ samples at some time point, I can consider that the corresponding mean would be unreliable, and I prefer to set it as missing. And else, I can keep using BLQ samples at 0. Then this section also allows to check that the mean samples are not below a global limit of quantification that I would set myself, because I could consider this case unrealistic. And in that case, I would prefer to again replace the mean sample by one of the usual options. But I will keep the initial simple rule like this. And once I have defined these 2 settings, I can perform my NCA as usual. So I can first check the estimation of lambda z, which is done on the mean profiles that have been calculated. And then I can run NCA. And after running NCA, you will see that the NCA parameters for each mean profile is shown in the usual table of NCA individual estimates. In the table of concentrations, we see the individual data, and I can hide them like this to see only the summary statistics in each group. So this table is by default, it is stratified with the same stratification that I have specified for the sparse NCA. And the mean rows for each group are highlighted in green because they correspond to the mean profiles. So I have a first mean profile here, and then if I scroll down, I can see my other mean profiles that have been calculated like this. And in the plots, I see the NCA individual fits based on the mean profiles and the NCA data plots that shows both the individual data and the mean profiles calculated the same way as for the Sparse NCA. And this concludes my demo of the PKanalix updates. So now I will move on to Simulix. So I will open Simulix. And I will begin by importing to Simulix the Monolix run that I have shown you during this webinar. If you remember, it is this Monolix run has a fixed covariance effect of weight on the volume and the clearance to allow allometric scaling. So load it like this. And so I have my covariate, my covariate weight that is constant with the values imported from Monolix. But here I could just define a new distribution of weight corresponding to a human population to scale the human to the model to human predictions. But I won't do it to save some time. I want to use this chance that I have a model with a regressor, with a dose regressor, to demonstrate a new option to define a regressor element. So instead of defining manual values or values from an external file, we can now also define a regressor as a distribution, like for the covariates. And this means that every simulated individual will have a different and constant regressor value from this distribution. And this is not very useful here for those, but it is very handy if some of your regressors are parameters like PK parameters previously estimated and used in a PD model, because then the distribution represents some inter-individual variability on these parameters. So to show you other new features in Simulix, I will now actually come back to the first project that I have shown you in PKanalix with the PK profiles in day 1 and day 14, in which I have also estimated a simple PK model with compartmental analysis. I can show you quickly the results here. So I can export this project to Simulix, and this project has several covariates. And previously, these covariates could not be exported into Simulix because only covariates used in the statistical model, and so that had an impact on the simulations, were exported. And CA models have no statistical model, so no covariate was exported from PKanalix. Now I have the option here to include all the covariates that I want, even though they won't impact the simulations. And this can be actually convenient if you want to resimulate the same individuals and stratify the simulations by some covariates, or if you want to define a treatment with the amount scaled by a covariate like weight, for instance. So after exporting, I see here the model that was used for compartmental analysis in PKanalix, which is a simple PK model that has no statistical model. And now if I want to simulate it with inter-individual variability, so this works for a model imported from PKanalix like this, or it could be the same issue for a model that I have selected directly into Simulix. I need to edit that model to write the statistical part of the model, which is quite time consuming and error prone. So to accelerate this process, we now have this new button, Add Individual Block, that automatically edits the model with a new block that is here with a default statistical model, where each parameter is described with a random effect and a log normal distribution. And now I just have to edit this statistical model if I want to change the distribution or remove a random effect. For this demo, I will keep the default model, and I need to save it. Save it, let's say, on my desktop. And now I can define population parameters, population distributions for the parameters here. But actually, I will now load the same project that I have already modified with some population distributions to make it faster. So I have defined population distributions around the geometrical means of the individual parameters estimated in the compartmental analysis of PKanalix. And in addition, I have defined 2 new treatments with multiple doses with medium or high levels of dose. And I have set up 2 simulation groups of 30 individuals in each group that receive the 2 different treatments. And I have run the simulation with 100 replicates. In the plot, so first you can see the new plot presets available here as well. And while I am here, I can mention a small detail. In the plot output distribution, we have a new toggle here that allows to hide the percentiles in this plot if you only want to compare the simulated medians between groups. And that can be convenient if you have many different groups. Moreover, I have defined a simulation endpoint that is here that I won't take the time to detail, but the goal is just to check whether this endpoint is significantly different between the 2 groups. So as in the previous version, the result for the group comparison that is here, we have the percentage of success that corresponds to the percentage of replicates for which there is a significant difference. And this percentage was given without estimation of its confidence until now, although the confidence in this value increases with the number of replicates. So an improvement of this result in this new version is the addition of the 25% confidence interval. And lastly, in Simulix, as in Monolix and PKanalix, you can now open a new information window here with all the details about your license. So you will have the information about the type of license, the expiration date, the apps it is valid for, and you can also validate the license directly from there. So this concludes the updates in Simulix. With the few minutes I have left, I would like to mention briefly the main updates in our Lixoft connectors R package. So first, of course, every new feature has a corresponding new function in the package. Then we have also enhanced the documentation for the Monolix and PKanalix connectors to provide more guidance and working examples. All the plot functions, such as the plot VPC, for example, are much faster and have also a better consistency of settings with the graphical user interface. We have defined a new function called print simulation setup that displays everything that is set up for simulations in a Simulix project. And also a new function, print outcomes endpoints, that displayed all the outcomes and endpoints defined in the Simulix project. And this is it. So I hope that you enjoyed learning about the new features of MonolixSuite 2024. We are very excited to see how you will use our software to advance your modeling and simulation projects. If you have any questions or feedback, please feel free to contact us with the feedback form integrated in the interface, or you may also find some answers on our online documentation. And before I end this webinar, I will just take the opportunity to promote our upcoming workshops at the PAGE conference that will be in Rome in June. Have a good day.